Jonathan Wilkie with the SIMT.
Can everyone hear me?
Yeah.
Testing. Okay. Well, my name is Jonathan Wilkie, and I am responsible for all the operations running through the RP Center, as well as laser scanning, well, RP, additive manufacturing. This is an asset that we acquired here about a year or so ago that really links virtual reality really well in RP. It sort of puts all of them together. You can take assets that you use this equipment for straight into additive manufacturing or straight into virtual reality, whichever one you do. I'm going to show you guys two examples of how we use this. The first example is one of my favorites, is measuring and quality control for parts. The nice thing about this is being able to take a part that just comes off the production line, scan it, overlay it on the CAD model, and then you can look at any variations you have. Second thing I'm going to show you is reverse engineering, where we can take a legacy part that is like Jay Leno application, and we can scan it, and we can reverse engineer it, make a CAD model for down the road, or we can actually use it to produce parts. So, the equipment I have here is this here is Ferro's, not their latest arm, it's one rep below their arm. It's an 8-foot working area arm. And so it's a 7-axis portable CMM. We got a touch probe here. And then on top we have a laser scanner. Okay? So we really have two systems in one with this. The laser scanner is Ferro's new scanner. Their latest one is called ScanArm V3 laser scanner. The accuracy of this scanner is 35 microns, so right under 2000s. The accuracy of the touch probe here is 30 microns, so it's pretty accurate as well. And as you can see, we can get in all kinds of tight areas because we got 7 axes to move around and do all kinds of various intricate parts and jobs. One of the first projects we did after receiving this was a part for ABB, and this is a part here. And what this is used for high voltage applications. And actually, the white piece you see here is two SLS parts, mirrored copies of each other. The story behind this is ABB came to us and said, hey, we're having some issues with the part, the way it's being manufactured now. They're having to do some post-processing work, some billing and that kind of thing on this part, and we're just not getting the kind of results we want. So can you scan it, make us a CAD model so we can take it to look at a different process without having the post-processing work on it? And we said, yes, sure, we can. And they also wanted to look at some different variations on it for quality control. So they wanted to scan this, reverse engineer, and they wanted to, like I was telling you earlier, use the qualify process to look at the different variations between the CAD model and the real world part. As you can see up here, the first part on my right is the greenish part, and that's actually point cloud data. The way this works is you scan the part, and it takes about 19,200 points per second, and you create what we call point cloud data of the part. And then we take that point cloud data and we wrap it with polygons. So we triangulate it, and we make the second model that you see, the blue. Well, this is qualifying, sorry. So we have point cloud data. I'm getting ahead of myself here. And then we have the CAD reference. And we take that point cloud data, we overlay it on the CAD part, the real world, or the CAD part, and we have the real world part. And then we get this, as you see here, this is qualifying. What this is a color spectrum analysis of where the part is in spec and out of spec. The red areas and the dark blue areas obviously are out of spec. The green areas are within spec. So you can see this part is pretty out of spec. And it verified the results they were getting with the part after it was had some post-processing work done to it. The second capability of this is reverse engineering. We use the software. The software package is called GeoMagic, and the qualification is GeoMagic Qualify. The reverse engineering portion of it is GeoMagic Studio. And what we can do is we can scan it, scan this as you see up here, create a point cloud data again, which is the green part. The middle part is the polygon part, where we wrap it with polygons and triangles, and we do some surface cleanup work on it. And then the last part that you see, the goldish color part here, is the actual CAD model. Now in the middle stage, we can make it a solid volume part and actually export it as STL. So then we can take it straight into additive manufacturing technology. Or, in the last one, we can make a CAD part, an IGES or a step file that you guys can take and put into your CAD system and make changes or whatever you need to make to it. I'm going to show you guys a real quick demo of how this works. Is anybody here familiar with this process already? Has anybody seen it before? Okay, so we got a few people here familiar with it. There's several different scanners out there. There's one called a Handy Scan. It's a little more portable than this one. It's more of a handheld with, I think, a 30 or 35-foot cord on it, so you got a pretty large envelope of working. This is a little more accurate than the Handy Scan one. Handy Scan is used for scanning car bodies and car doors and that kind of thing. This is more for part applications, very tight tolerance parts. But as you can see here, when I press the button and start scanning, you'll see some point cloud data showing up. And that's part of the valve here. It's a little difficult up here because we do have movement on the stage and not sitting on a very stable surface, but you get the idea. So, there you go. That quick, you get a portion of the part. The other thing we're talking about part verification is qualifying and being able to pull different annotation points on your part. You can actually take the part that we make for you for scanning and overlaying on your CAD model, and you can download a free software to you can actually download a free software and take a look at it yourself and pull different points you want. Sorry about this, fellas. We got several different. Well, there it is. So here you go. Here is the color spectrum analysis on the part-for-part verification. And as you can see, as I pull parts here, it gives me different data points, comparing the CAD model to the real-world part model. And of course, the reverse engineering using geometric fashion. And that's really the gist of it, the basics of it. I mean, it does get a lot more involved with that, especially when you're doing reverse engineering and having to do cleanup work on your CAD files and your polygon models and that kind of thing. But that is the gist of how this process works. Any questions? Yes? Scale limitation. Well, this is you got an 8-foot working area with this on. But what we can do is we can scan certain portions within the area we are, and then we can move it, scan next portions, move it, and keep on scanning until you get the complete part scanned, and then you can merge them back together using the software. But in a static position where you are, you got about an 8-foot working area. Any other questions? Yes? It would be very difficult with this arm. What you would use for that is a Handy scanner. It's a handheld scanner, and it's got 3, looks like little eyes on it, and then one in the middle and then one down at the bottom of the handle. And where's Bill Watson? Bill back there with Anvil? He does handy. He has a handy scanner, and he does a lot of big car bodies and scanning cars and that kind of thing. Can I mention the NASCAR application? They scanned the body, NASCAR body, and overlaid it on the NASCAR, the template that NASCAR has these new templates now, and they have a perfect body, and they scan each car body and overlay it on that perfect body to see the different variations, like you see here. See where they need to take not the sheet metal in, pull it out, some of that kind of stuff. And that would be the handy scan. Any other questions?
I'll tell you what.
I know that was sort of quick.
No, that's okay. Can we, while you continue to take a few questions, can we go ahead and swap out the? So, if continue with some questions you might have.